So, chapter 3.1 terminology. First thing we know about matrices, or need to know, is what it is. So, a matrix is any rectangular arrangement of numbers. Those sounds fantastic. So, usually a matrix is denoted by like capital letters, so it would be like A equals terminology. Okay, an example of a matrix is something like A equals 6 and 7, and we got these nice little rectangular brackets. So we know what the matrix. It can come in all shapes and sizes. So we have something like B equals, we have 6 and 7. Okay. Something a little bigger. So we just have basically a bunch of numbers and these rectangular brackets on either side. So our second little definition here. Dimensions in order. We give the dimensions of the matrix, state the number of rows, and then the number of columns. That's all you gotta do for that. So if I have a matrix like this, how many rows do I have? First of all, what's a row? Rows go this way, yep. And columns go this way. How many rows do I have? 1, 2, 3, 4. I got 4 rows. How many columns do I have? 3. So it's a 4 by 3 matrix, we say. Or we can write it out as, see this? F with a little 4 by 3. I'll say you know F is a 4 by 3. You just want to make sure you don't confuse the rows and columns. Then you're just in a world of trouble, I guess. So, once you can figure out the dimension of your matrix, you can find the elements or entries of it. So, in that matrix, the last example, if I want to find the entry in the second row, first column, the F, row 2 and row 1, don't have the X in between anymore, so that's the entry in the second row, the first column. What would that be? Let's make it see. Second row, first column, yeah. That's 4 right here. So we just say F1, 4. What about F3, 3? 6, we find our third row, third column. That's all you got to basically do for that. And now we have a bunch of stuff here. Okay, guys, so here we just have some pretty straightforward definitions. So a square matrix, it has the same number of rows and columns. You're going to know that because it looks like a square. You guys handle that with an example. Same with a row matrix. It's just one row straight across. Column matrix, one column. Zero matrix, everything's zero. Any questions with those? No? That's all looks like we just love matrices. So now we have the transpose of a matrix. After we have a matrix, we switch the rows and the columns. I know it sounds awesome. Matrix. Is any rectangular arrangement of how many is that? add something like this 3x4 matrix A. I want to make the transpose of it. All I have to do is take the columns, take the rows, and then I make them into columns. Kind of sort of. But we're still, once we make the transpose, it's still rows by columns. So to get A transpose, I'm going to have A, a little p up top, so we know what the transpose. And then I make the rows into columns. So this first row here, I make it into a column called 7, 6, 12, and -4. And then take the second row, and I do the same thing. I make it into a column. Just listen, exactly. What's that? Just write down what I go. Don't try to prove. I'm pretty sure I'm doing it right. So you start off with like a 3x4, and then we switch it, it becomes a 4x3, right? Any questions on this? We're just taking the rows and turning it into a column. Well, that's what you think, but you don't. So, okay. Whatever. That's all we have to do for the transpose. Okay, so for the quality of matrices, both matrices have to have the same dimensions, and then the corresponding parts. You're basically exactly what's written down there. Any questions on that? The wording on that? Yeah. Corresponding. So that means the entry in the first row, first column, equals the entry in the first row, first column, the other. So y equals 2, and what is x equal? So each part of each matrix is equal. Right? So you write x's and that.